The Economic Value of Restoring Wetlands by Claire Momberger, March 6, 2019. The rapid loss rates of wetlands around the world and the realization of their value have motivated the recently fervent efforts to restore these complex but crucial systems. Wetland restoration can occur in efforts to replace habitat for species like vernal pool fairy shrimp or waterfowl, to repair coastal shores, or to restore formerly mined peatlands. There are even policies, such as the no net loss of wetlands in the United States, that have encouraged wetland creation and restoration and made these activities into an actual industry. The process of wetland restoration is based on these four components of wetland science: the hydrology, the biogeochemistry, adaptations, and succession. It is crucial to understand how these four components bring life and balance to a wetland before a wetland can be revived. Wetland restoration refers to the return of a wetland from a disturbed or altered condition caused by human activity to a previously existing condition. Gosling and Mitch. Wetland restoration is different from wetland creation or wetland enhancement because it involves the reestablishing of previous conditions that have been previously altered or degraded. As was mentioned before, wetland restoration has basically become a new industry. This push for restoration in the culture is not always voluntary. It can result as a product of government policies like the aforementioned no net loss policy in the United States. However, the protection and restoration of wetlands is undoubtedly needed. The percentage of wetland loss around the world is staggering. The percentage loss of wetlands in New Zealand is more than 90%. Australian wetlands, including the coastal New South Wales wetland, is more than 50%. The Philippines have lost almost 70% of the mangrove wetlands present. The Pacific coastal estuarine wetlands in western Canada have lost almost 80% of their area. The United States has lost almost 60% of its total area of wetlands. One example of wetland degradation in the United States is along the Illinois River in Putnam County, Illinois. The Hennepin and Hopper Lakes Restoration Project objectives were to restore the prairie, the savanna, the two lakes, and the wetlands on the site in order that the quantity and quality of habitat for fish, waterfowl, and other wildlife were improved. Here is a picture of the restoration map delineating the different plant communities that were restored. To evaluate and compare the economic value between the agricultural production that was occurring before the project and the conversion of that land to wetlands, the impact modeling for planning IMPLAN model was used. The IMPLAN takes into account the change in total economic output, household income, and employment associated with changes in the economy. In the case of this project, the change considered would have been the conversion of corn and soybean crops to wetlands. The IMPLAN process suggested that this wetland restoration was economically efficient and had positive economic impacts on the regional economy. Hay and Prato, 2011. With the estimated annual net benefit being $1,827 per hectare of restored wetland. This totaled out to a net benefit of $1.83 million in favor of the restoration project. Some of these benefits were the positive economic increase due to heightened recreation because of the improved native plant and animal habitats, the value of reducing nitrogen loading into the Gulf of Mexico, the decrease of agricultural production loss, which usually occurred due to flooding events, and even the government savings from not having to pay subsidies on crop production. Another place where wetland restoration, specifically peatland restoration, has been considered and its impacts on the economy have been analyzed is in the United Kingdom. Upwards of 80% of peatlands in the UK have been destroyed and degraded due to atmospheric pollution, burning, cultivation, drainage, and grazing. This degradation of peatlands has caused a subsequent degradation in ecosystem services, like those of climate regulation and water quality regulation. In a study completed in 2014, a cost-benefit analysis on the restoration of the peatlands was conducted. In this study, the restoration was set to involve raising water levels, reestablishing bog vegetation, reducing grazing, and stabilizing areas of bare peat. This restoration would improve the quality of the peatland as a carbon sink, but also improve water quality, flood management, and habitats and diversity. Because of the significance of peatlands as carbon sinks or carbon sources, the conclusions of this study suggested that cost-benefit analyses be conducted by analyzing the carbon and non-carbon benefits separately in the future. Assessing the economic value of restoring a wetland is just as much of a social or cultural issue as it is a biological or physical science and economic issue. Because the restoration of wetlands sooner comes at the cost of the taxpayer than that of the landowner, public opinion often plays a large role in the restoration of a wetland. In 2011, a study was performed to evaluate the willingness to pay, or WTP, of the residents of Manitoba, Canada, for wetland conservation and restoration programs. The WTP of a community can become an inhibiting factor when organizing support for wetland protection and restoration programs. Even when communities wish to see wetlands protected and restored, the thought of that cost coming out of their pockets instead of landowners can prove difficult to comply with. Education of the ecosystem services provided by wetlands may garner support for wetland restoration. The restoration of wetlands can serve many purposes. It can prevent the further deterioration of existing wetlands. It can mitigate the loss of fisheries. It can reduce land loss. It can provide protection from hurricanes, storm surges, and floods. It can even improve water quality. Having wetlands present in our environment allows for a natural regulation of climate, a cycling of nutrients, and many more ecosystem services. There is minimal literature that surveys the success of wetland restoration projects and the subsequent benefits to communities and local economies by way of wetland restoration. However, the undeniable health that wetlands offer a local environment should be considered a scale tipper when it comes to assessing the value of restoring wetlands. When considering wetland restoration and creation in your community, remember these two basic but significant guiding principles. 1. To restore a wetland, you must first understand the science behind it. A way to stress the importance of this fact is the metaphor of fixing up an old car. To be successful at restoring a 1967 Ford Mustang, you would first familiarize yourself with the mechanics of the car, the location of particular car parts, and how those parts work together. The same is true for a wetland. To ensure its health and longevity, the chemical, physical, and biological components must be understood separately, but more importantly, as a system. You must understand the system that a wetland is before you can restore it. The second principle to remember is that when restoring a wetland, the desire to over-engineer, over-botanize, or over-zoologize the wetland that you are restoring must be resisted. Wetlands are some of the most sensitive yet most vital landscapes found in our environments, and for this, their protection should be of the utmost importance.